Now we will be solving question number 8.15 from the book of by Beer and Johnston on vector mechanics statics. In this question, it is being said that a 40 kg packing crate must be moved to the left along the floor without tipping. Tipping means there is some friction here, and due to the application of this force P, it may topple. Okay, so we do not want it to topple. So knowing that the coefficient of static friction between the crate and the floor is 0.35, determine the largest allowable value of alpha and the corresponding magnitude of force P. Now what will happen beyond a certain value of the angle alpha, it will have a tendency to rotate about this point. Say this point is C. Okay, let's just name the points. So now our aim is to find the value of this P, this force P and alpha, so that the block doesn't topple. Now first of all, as in every question, we will try to write out the variables. Now mu is known, W is known. Now there will be some normal reaction here. I have shown it with dotted line because of a reason which I will discuss later, and there is a force W. W is known. It is given to be 40 kg force. Now when I convert it, it becomes 392.4 Newton mg. Mu s is known, is this 0.35. Now first of all, I will determine the total number of variables. Now there are two variables, f, p and alpha. N can be found out. How? Just write sigma f y is 0, considering these set of axes. So we can say that p sin alpha plus n is w. So n comes out to be w minus p sin alpha. So n is not a variable anymore. Now just see, there will be some shifting of normal reaction to avoid the toppling. This normal reaction, instead of acting here, will act at the cornermost point C, like this. That's why I showed it to the dot line. And the reason being that this normal reaction can act anywhere here, but it will try to offer as much resistance as possible to the toppling nature. To do that, it will just act toward the leftmost available point, because it can provide more torque. If you see about the center, it can provide a net torque here. Okay, more torque here for the resistance. That is the exact reason why if you have a sphere on, say, a rough plane, even then it will roll because the normal reaction can move nowhere. But if you have a crate on a plane, the normal reaction shifts to this point so as to avoid the toppling as far as possible up to the angle of repose. So normal reaction will be acting here, and then there will be some friction force mu n. Okay. So now just try to write the equations. First of all, we need two equations, okay? Because there are two variables p and alpha. First of all, we write sigma fx is equal to 0. So sigma fx is equal to 0 gives me that p cos alpha equals to the friction forces. I'm sorry, friction will be acting in this direction, will be equal to the friction forces. Now just equate it, equals to mu n. So mu times n is nothing but w minus p sin alpha. Okay. Now next thing, we have to see the moment balance. Suppose this is my z axis. Now this equation was obtained by mx is equal to 0. Sorry, sigma fx is equal to 0. Now just try to calculate the moment about this point here, C. Now when I say about the point C, the normal relation and the friction force pass through this point, so their effects, their moments about this point C will be 0. So I can simply say that this moment by this force P, P cos alpha and P sin alpha. This is P sin alpha, and this P cos alpha will be, now these both tend to rotate it in the clockwise direction, in the anti-clockwise direction. This W will try to rotate it in the clockwise direction, so the efforts must be equal so that it doesn't topple. So I write .5 okay, 0.8 this is obtained by sigma m z is equal to 0. Now if you see here, mu is known 0.35, W is known 392.4 newtons, and what else? Just P and alpha. So you can easily solve this equation for P and alpha. Thank you.